Thank you.
Take a group photograph. This may be the best opportunity.
Okay, welcome back from the break. The session on electrification and decarbonization will begin shortly. I'm Dr. Tim, Program Director of the Fuel Cells and Hydrogen at the Irian Energy Research Institute. I'll be the MC for this session. So please be reminded to have your microphones and camera disabled during the webinar to minimize bandwidth load. The web link to download the speaker slides will be made available to the participants from SPEC's website after we have received your feedback forms. So we have about 5 minutes at the end of each talk for Q&A. So please type in your questions in the chat box and I'll read your question from there. So it's my pleasure to welcome the first speaker of the session 2, Mr. Les, HVDC converter and submarine cable specialist from Amplitude Power. He will be sharing the topic on HVDC and renewable energy transmissions. So Mr. Les is an experienced electrical engineer with over 26 years of experience in the transmission and distribution. Currently, he is leading several HVDC engagements in Australia and overseas. So Mr. Les, are you able to share the screen right now?
Okay, thank you. Give me a sec. Right, can you see that?
Yes, but
okay.
Hold on a minute,
okay.
Please. Stop sharing. Yeah, how to stop sharing. Sorry, yeah, we are having some issues with the screen right now.
Yeah, the red button.
Oh,
Red button.
Oh yeah, sorry. All right, so we got it. Yes, it's good.
Okay, can you see that?
Yes, you want to go to full presentation mode? Yes, good, it's good.
Okay, great. Okay, good afternoon, everyone. Thank you for the opportunity to talk about HVDC. My name is Les Brand. I'm the Managing Director and co-founder of Amplitude Consultants. Joining me tonight is Matt Gnad and Dr. Ki-Han Chan. Now, Dr. Chan is based in Singapore. Amplitude's been established since late 2015, and in early 2020 we established an office in Singapore. So today what we're going to do is we're going to talk about my favorite topic, HVDC, talk a little bit about the key technology and benefits, global application, particularly as it pertains to renewable energy, and potentially opportunities for Singapore. So we'll start off with what is HVDC? Well, it stands for high voltage direct current, and in its most basic form, HVDC is converting power from AC, which is what we all currently use and transmit. We convert it to DC, we transmit it a certain distance, often a very long distance, and then we rectify it at the other end. We invert it at the other end. We convert it back to AC. As you can see, there's some terms here. There's a rectifier, which is the converter that converts it to DC, and the inverter, which is the converter that converts it to AC. And in between, it can be a DC overhead transmission line, or it could be a cable, it could be a land cable, or it could be a submarine cable. So why is HVDC used? Well, it depends on the application, but some of the key applications for HVDC include lower transmission losses. So the converters have high losses comparatively compared to an AC substation, but the losses in the cable or the overhead line tend to be a lot lower compared to AC. Also, there are technical reasons or technical issues associated with very long AC underground or submarine cables. So whenever you have an application that requires cables, long lengths, rule of thumb is for the very high voltages, somewhere around the 50 to 100 kilometre, often HVDC becomes your only option. Lower transmission costs, again, talking about the transmission line in between, the cost per kilometre tends to be a lot lower than the AC equivalent. Controllability, there are applications where you do want to control the active power flow coming in and out of your system, or if it's within your system, going across the transmission line. Interconnection between two unsynchronized networks, or networks of different frequencies, and often to minimize the risk between interconnected networks. And what that means is that an AC transient or a disturbance will not be transferred through the HVDC to the other network. Generally, there are two technologies that are used in HVDC. There's the line commutator converters, we call them LCCs. They use thyristor valves to commutate the current, and they've been around since the mid-1950s. Since the early 1970s, they've started using thyristors, but before that, they used mercury arc valves. LCC technology is still used. It's often used more for very long distance, very large amounts of power, very long distance overhead lines, or projects that require a large amount of power. Voltage source converters, or VSCs, instead of using the thyristor valves, actually use devices called insulator gate bipolar transistors, or IGBTs. These are self-commutating. The conversion from AC to DC is done through switching these IGBTs on and off, and essentially developing an AC waveform or a DC and simultaneously a DC voltage waveform. This allows complete control, what we call 4-quadrant control of active power and reactive power. The first VSC technology was introduced commercially in 1997 or the late 90s, and the second commercial VSC project was actually built right here in Australia. So the differences with VSC, I've got another presentation that I often give which actually explains the technical differences, but generally when VSC was introduced, it opened up a whole new series of applications for the HVDC technology. So for example, low power. Prior to VSC, high power projects were the only use for HVDC. If it wasn't a gigawatt or 2 gigawatts, it wasn't really viable. VSC opened it up, and now you can actually find there are 60 megawatt, 100 megawatt VSC applications. And of course, one of those is to power offshore loads. So for example, if you've got an offshore oil platform that you want to get power to, that's an application at the lower power end. Offshore generation is obviously something that's really picked up in the last 10 years. So very, very large offshore wind farms are using the VSC technology to collect all the power offshore and then transmit at a very long distance to the shore. As I've mentioned there are a couple of projects that can get up to 800 megawatts. I'm sure there are going to be bigger projects as time goes on. Remote passive loads using overhead lines, again, another application for very large countries where you have relatively small loads, but a very long distance away. So VSC has enabled that. What's very important at the moment, interconnection into and out of a weak network. So a network without very high system strength. VSC can handle lower short SCR or lower or weaker networks better than an LCC can. And finally, small footprint applications. VSCs don't require banks of AC filters to be able to operate. They may require some filtering depending on the application, but generally speaking, you can get the footprint down to 25–30% what an LCC VSC would actually require. This is an image. This is an example from a Siemens VSC converter station, but essentially this provides shows you a number of key areas. Number one, the orange is the valve hall. For a multi-level VSE, it's essentially a room full of capacitor banks with IGBTs, allowing the capacitor banks to be switched in and out. Item 2 shows some converter reactors. Item 3, the cooling system, and 4, a control room, auxiliary supplies, and so on. So that's essentially, they're essentially the main components of a VSC converter. History and development of the VSC. So we have our first commercial, HVDC project in 1954. You could see New Zealand just across the water from us, built one in 1965. So HVDC as a technology has been around for a very long time. It went through various technology stages, but the line here is when VSC became commercially available. And so prior to that, it was only LCC available. After the late 90s, VSC is available. The first multi-level VSC was commissioned in 2010 or put into operation in 2010. That was a Trans-Bay Cable project in San Francisco. And from there, the VSC in particular started getting larger and bigger, and so on. And you can see also that LCC technology also continued to develop during this period as well. So with 2019, the first 1.1 million volt LCC project in China. So global interconnections. So the VSC HVDC has now opened the path for global interconnections, the connection of one country to another. There are a number of reasons why that could be attractive. You can allow one country that has a large amount of renewable energy, solar, wind, hydro. If they've got more power than they consume, then they can transmit it to another country. That's most certainly possible from a technical perspective. It also gives you the advantage to the possibility to take advantage of time zones. So sometimes some areas where the sun is shining and there are big time zone differences, you could bring the power in where it's no longer needed, and pull it into somewhere else, which is actually going through a bit of a peak in their demand. So you can really take advantage, a bit of arbitrage between time zones. It allows countries with minimal solar resources to be able to achieve renewable energy targets. So if you don't have the land for a lot of solar or for a lot of wind farms, HVDC provides the opportunity to get renewable energy from one location to that location. And, you know, not all connections are going to have to be a HVDC. You know, HVDC is expensive. It is, you know, compared to an AC equivalent if there are no major technical issues with the AC. But on the other hand, sometimes HVDC really becomes the only viable option, or there are a number of technical or project-related reasons, like it's too, you know, very long distance, where HVDC actually becomes the most economical option. So, as I mentioned before, renewable energy. So, I strongly believe there's a place here for HVDC technology to help remotely located renewable energy resource-rich regions to be able to provide power to other countries. And, you know, from a technical perspective, the distance that it needs to transmit doesn't really matter. And as I mentioned, my third dot point, sometimes the opportunity is only viable with HVDC. But HVDC also has a whole lot of other, well, particularly VSC technology, has a whole lot of other technical benefits. You can couple the control systems with batteries. You can to allow, you know, a bit of a charging and discharging cycle to provide a more flat generation or import curve. HVDC links are dispatchable and controllable. So in an emergency, if you need to turn it off or ramp, or what we call run it down, you can run it down. If you need to run it up, you can run it up. It can go very, very quickly. So sometimes those benefits can really, really be utilized. And just the fact that, as I mentioned before, this 4-quadrant control allows you to actually be able to not only control your active and reactive power in both directions if you need to, but you can also control reactive power, which means you can put it in voltage control, and it can act like a STATCOM in that respect. There are other controls as well. Frequency control, you could use it to follow the frequency or provide some kind of control if the frequency starts to dip. And of course, black start. Now, VSEs can be used to help black start the network. And finally, HVDC can be designed to provide a continuity of supply whenever there is an equipment failure. So if you build 2 poles, one pole goes out, the other pole can operate at 50%, and then that pole can even be, if it's designed to, can even be overloaded a little bit to actually minimize the impact. And finally, opportunities for Singapore. So some of the things I've mentioned: power import, being able to bring renewable energy in from potentially a long distance away, the additional grid support, the reactive power, the frequency control, the ability to be able to control it, and also the potential for Singapore to be a larger part of it, or part of a larger interconnected network. So, for example, the ASEAN power grid. HVDC would allow Singapore to connect to countries where the distance would not allow AC transmission. Plus, as I mentioned before, a disturbance in one country will not be automatically transferred to the other. Commercial opportunities. There's an opportunity here for example, for a Centre of Excellence in Singapore to encourage other companies to come and bring in HVDC expertise. There are many years of expertise out there. Employ highly skilled employees, train people in HVDC, and the thing that, and also some research and development. But the thing that I find most exciting is that if you're a country that develops enough HVDC projects locally, you can actually export that capability and sell that knowledge to other countries in a similar way that, for example, New Zealand, Canada, and Europe, all of which established a HVDC link and then took that knowledge and established a good Centre of Excellence and knowledge sharing. So I think that's my time up. So thank you very much.
Yeah, thank you, Les. Let me see whether there's any questions that's flowing in. Okay, Les, maybe a question from our side. What do you see are the gaps or challenges in implementing HVDC?
Sorry, the challenges?
The gaps or challenges in implementing HVDC. What are the gaps and challenges?
Probably the biggest challenges with HVDC is the amount of time. It takes a while to build a HVDC project, often a lot more than an AC project. So there's a fair amount of engineering you have to do up front. Then you have to get these converters built. You have to build the cables and so on. Technically, you do have to do the proper studies to make sure that there are no technical issues with connecting it. And then finally, it's often the economics. So as I mentioned before, HVDC, sometimes you don't have any other option, or sometimes HVDC is more economical, but then in other times, it might be slightly, or it might be less economical than an AC option or another option. But then you need to work out how do you account for all the other benefits that you get with it: controllability, reactive power, STATCOM capability, and all of that.
Okay, I think you mentioned in your presentations that for a certain distance, HVDC might be viable. Is there a rule of thumb which says that when we should use HVDC?
if it's overhead, it depends on a lot of factors. So overhead transmission lines, it's usually a very long distance. It's hundreds of kilometers, possibly depending on the size and the megawatts and the kilovolts. 300-400 kilometers, 500 kilometers overhead line. But again, depends very, very strongly on how many gigawatts or megawatts. When it comes to cables, the underground cables, the submarine cables, there's a rule of thumb between 50 and 100 kilometers, where it's just not technically practical to transmit with underground with the AC cables, because they have to be discharged as a part of the AC cycle.
Okay, we have a question from the audience. They are asking that how do you protect the HVDC system from damage, such as from earthquake?
There are quite a few. So my last project, or my second last project, was in San Francisco, which is a very high seismic area. So, you know, but basically the applications that apply to any infrastructure, you do your shake table, you design your structure. But a common way to protect HVDC converters is that they hang the valves from the ceiling. So if you look at a lot of pictures of inside the valve hall, a lot of that is done for seismic reasons. But a very good example, if you can find a paper on the recent New Zealand Pole 3 upgrade, and they have published a few papers on that, you could actually see some very interesting technology that's been put into managing the seismic.
Okay, thank you. So, okay, so next we have Ms. Justine Nguyen, Smart Grid Research Manager of EDF Lab Singapore, who will be presenting on the integration of hydrogen and grid for energy network. So Ms. Justine oversees the mobility and hydrogen technical activities and support EDF in APAC area. Prior to this position, she has worked in different EDF R&D centers in France and China on grid and mobility topics and for the transmission system engineering of EDF CIST. So Ms. Justine, please.
Yes, thank you. So thank you for having us at this presentation, for doing this presentation, sorry. So I'm going to present decarbonized hydrogen and integration into the grid. So I am, as you mentioned, from EDF Lab in Singapore. So next slide, please. Maybe the agenda of this presentation. So I will introduce very quickly the EDF group, and then move towards hydrogen and our strategy, which is really linked with low carbon hydrogen. So how we can promote and what we do in low carbon hydrogen. And then after, I will investigate and dig deeper in hydrogen and renewable energy coupling and electrolyzer flexibility. So two topics that are really linked with integration of low carbon hydrogen into the grid. And so I will give some examples of projects and also present our electrolyzer testbed. Yeah. So EDF, in fact, we are a world's leading low carbon electricity company. So we are well established in Europe, but we also have some activities in America and in Asia. We are, in fact, a group that operates in more than 27 countries, and we are present in all electricity business lines. What is important for EDF Group is also to build a net zero energy future with electricity and innovative solutions. I think this is very important because it is also all the purpose of the hydrogen direction where we are going to. It is also to provide low carbon solution in order to achieve and to help our clients achieve a net zero energy future. Next slide, please. What we do as EDF in order to develop these services is really investing into innovation. So innovation is really at the heart of our group's performance. And so we have the R&D contribution. So that's where I'm from at EDF Lab. We also work with different startups in the topics, and we are divided in several business lines. So some, for example, in smart city, electric vehicles, batteries, aggregation, but the last one that is the most important for us today is the Hynamics, which is the business line which is dedicated to hydrogen. And so the goal of this, yes, thank you. The goal of this subsidiary is really to focus on high performance and low carbon hydrogen for two kinds of users, industry and mobility. And so this brings to the next slide. Which is our strategy, which is really focused on low carbon hydrogen. So if we go first on the client and the use, it is focused on industrial and mobility, mainly heavy duty. And why? Because we think and we see that now it is the clients that are the more have this specific target of achieving carbon neutrality and are looking for low carbon solutions in order to help them to reach these targets. And how to do that? So we can produce hydrogen from gray hydrogen, so carbon and centralized production. This is very cost effective, but it is carbonized. And so that's totally not the direction we are taking at EDF. So we are not talking, when we talk about hydrogen, about this solution. Everything that is linked with steam reforming or with delivery, truck delivery to demand site, are producing, in fact, carbon. And so it is what we call gray hydrogen. It is cost effective, but it is not low carbon solution. So that's not our focus. Our focus, and as you can see here in the green box, it is the focus also of Hynamics. It is on low carbon solution. And what is low carbon solution? In fact, there are not so many different solutions. It is low carbon solution with water electrolysis, with consumption of green electricity, decarbonated electricity, so either from wind for PV or from nuclear production. And the goal is really to be close to the demand site to avoid to have all the emissions that are linked with delivery when it is produced far away. And then after to store or to have on-site transmission and a distribution of gas, and then after to serve the clients of industrial and mobility. So this is globally the context, and our focus now in R&D is really, so we have this, we know that there is this problem of competitiveness, in fact, of low carbon hydrogen, which is way more expensive than gray hydrogen. And so now our focus in EDF R&D is also to try to see how we can make the technology evolve, find new and innovative services in order to help this gap to decrease and to provide a low carbon solution that is also attractive in terms of economic price. So it is a long-term vision, but we really hope and we will think that this is the future direction for hydrogen. Next slide, please. So about our R&D contribution in hydrogen, in fact, it's mainly based on a center that is in Germany that have worked on hydrogen for more than 20 years. So the goal is to support the business unit, but it is really to also see how to increase the performance and life duration of electrolyzers. With a high temperature electrolyzer, fuel cell, and hydrogen compression. And what we do, and I think it will be after the key point of this presentation, is also participating in experimentation and demonstration projects on mobility, industry, so as mentioned earlier. And also we try and we have some interest in power to gas that we have tested in previous projects. Next slide, please. So now I'm going to discuss more about these references and the references we have in industry and mobility projects. So in fact, I'm not going to talk about mobility projects. We have some experience in it, but it is not the purpose of today's discussion. So I'm going more to focus on the two dark blue references, which are the R&D test platform. I'm going to finish with that. And the other one, which is an industry project and also some power to gas project. So the first example I'm going to talk about is Westküste 100 in Germany. So it is the one of our recent projects. So it's from last year, but it is a very big project. The goal is really to build green hydrogen, to bring green hydrogen to kerosene production. And so here, what is interesting, it's really having this entire system that will be the most efficient and the most green possible. So the purpose is to have a 30 megawatt electrolyzer that will be supplied by offshore wind in Germany. There is, of course, a European grant on this project. And so what we are doing at EDF and through AFOR R&D is support the development and evaluation of possible scenarios, including the extension of the electrolyzer from this 30 megawatt to 700 megawatts, define best solution, and also study the process and what will happen on the upstream of the electrolyzer. So really about grid connection, offshore wind, optimization, management of the electrolyzer and control of the electrolyzer itself, of course. And also that is really interesting in this project, products generated during the water electrolysis. So in fact, as you can see, there is this O2 that will be valorized. And there is also heat, the heat that will be generated that will be valorized. So the goal is really to optimize the whole ecosystem, and we hope like that to also find solutions to have a more efficient global system solution linked with green hydrogen. So this is something that is quite interesting, and not so many projects like that in the world. And so we hope to be able to produce very interesting results soon. After the other part, so we have several projects, but I wanted to focus on three additional projects. So next slide, please, sorry. And they are all linked with H2 and renewable energy. So in fact, the two different things we have studied and we are trying to demonstrate. So first, the potential of hydrogen is very important if it can be coupled with renewable energy and with low carbon solutions. So the goal is still on decarbonization. It is really our key message here. And so the first possibility that we have is what we call power to gas, and then power to gas and gas to power. So the principle, it is that you have a renewable energy production in excess compared to the electricity demand. And then in that case, you will have your electrolyze produce hydrogen. You will store it for a long term. And then after, when you need electricity, you will produce it through a fuel cell. So we have implemented some solutions like that. It is a very niche market because it is applicable in, for example, these two cases, high share of renewable energies in electrical grids. And the other one, that is the one that we implemented, microgrids with in-situ production. And the second part is more on how we can use this hydrogen to provide ancillary services. And so this is also something we are testing right now in Europe. So yeah, these are the key topics that could be linked with renewable energy. And so next slide, please, is this project on flexibility. How we can bring flexibility thanks to hydrogen. So there is a project we participated in. So it is in two parts. The first part was to build a hydrogen station for fuel cell vehicles. And the second part that is really linked with our flexibility question is, in fact, we are in charge of a lot that is dedicated to flexibility and to analyze how we can aggregate 20 stations of hydrogen and see how together they can aggregate and try to propose a solution for an aggregated solution for ancillary services and demand response. So the project is not finished yet. It still has 1 year to run, but the key elements that now we see, it's so first we have had to install a monitoring system for station operation data. So the goal is really to have this connected system. with all these 20 stations. And then after, now we see that it is very complex, in fact, to have this aggregated solution. You have to have the same signal for these 20 stations in order to have an aggregated answer. And the market mechanisms are not totally suitable for what we want to do with this H2 storage. So I think we'll have more results at the end of next year, but it is maybe our first challenges here with the flexibility and ancillary services for hydrogen. Next slide, please. So here it is 2 projects, one linked with flexibility and the other one, Mafate, which is really a project linked with power to gas and gas to power. So here it is totally the scenario where it's really this niche market, where it is a small aggregation of houses, 90 houses off grid with PV production, and you have 2 solutions, one short-term storage with battery and one long-term storage. So long-term here it's 5 days. With hydrogen and fuel cell. And so this technically it works. However, it is not economically viable yet. So it is heavily subsidized, but it works. And so that's, in fact, what is interesting for us is the fact that there is this potential that we see. Clearly renewable and H2 has a potential. But now the question we are asking ourselves is also, what are the impacts of this intermittency on the dynamic signals for flexibility requirements on the electrolyzer? And this is a question that for now is not analyzed. And so that brings me to the last part of the presentation. So next slide, please, which is our last test platform that we have now in EDF in Les Renardières, so it's in France. It is an electrolyzer test platform for low carbon hydrogen generation. It is really, the goal is really to study the performance and aging of electrolyzers linked with renewable energy intermittency and see how it reacts and how it ages according to the signals that we send. So the next slide shows the location where it is. And as you can see, it is mainly electrolyzers that are small electrolyzers, so 1 megawatt for now. We can install up to 2 electrolyzers. So this is the global characteristics. We are coupled with an RLC amplifier, with PV solution, with storage, flywheel, and electrochemical. And so with all of that, we can do all the scenarios we want to see the impact of intermittency on the storage and also the impact of the control strategy that we want to have. And so that brings me to my last slide, which is, yes, exactly this one. What we do test in this platform. So the goal is really to understand the flexibility impact. So we are measuring performance under normal and disrupted conditions at various spans and for various operating modes. And here it is essentially looking at the French grid code and ENTSO-E European grid code requirements for demand response, but it could be also applicable, for example, for Singaporean grid code requirements or other places requirements. Understanding the system deterioration, assessing the impact of disruption from the power grid, what are the impacts on the electrolyzer, and characterize the flexibility of electrolyzer, which is more complex than what people think. And the scenarios and case studies are assessment of electrolyzer ability to contribute to supply-demand balance. So this is really a key. And also trying to test different algorithms to optimize the electrolyzer management, taking into account the network requirements. So that's, yes, our test facility. We think it's a unique one to support the transition towards decarbonization. And we are certain at EDF that low carbon hydrogen is really a way for the future and for decarbonizing the entire system. So thank you.
Thank you, Justine, for the very informative kind of presentations. So, well, hydrogen and its applications, I think is getting a lot of attention right now. But you have presented a few cases which is rather specific to the Europe's that are specific to Europe's kind of conditions. I think for Asia we have a different set of constraints. How will you propose those countries which are still in the infant stage of looking at hydrogen and applications? How should they approach it?
Okay. So thanks for the question. So it's true that these projects are more for European countries. For Asian countries, so Asia is quite big and diverse, but maybe if we focus on Singapore, here we are also in discussions on the hydrogen project. And I think here the main challenge is the fact that the electricity from the grid is not low carbon, it's not decarbonated. So you have to find a way to produce this green electricity, either from PV or from interconnection, for example, as a solution that was mentioned just before. Then after connecting to an electrolyzer, producing this green hydrogen, are you able to certify that this hydrogen is green is another topic. And the key, I think, issue is still related with the cost. You have a lot of solutions here also on gray hydrogen, very cost-effective gray hydrogen. And so what is the appetite for local actors to go towards green solution, green hydrogen that could be produced in situ, and but will be more expensive? Is it something that is interesting or not? And that's really what we try to investigate also here at EDF by contacting local actors and seeing if there is this appetite, and we see that there is a real appetite here for green solutions. So
yeah. So I think one of the tools to incentivize the adoption of hydrogen and other green, other low carbon technologies is through the use of carbon tax. What do you think should be a range of, what should be the right value of this carbon tax so that it will be effective in accelerating the adoptions?
Okay, so I don't have an answer to this question. So exactly what could it be? What is sure is carbon tax is only one of the ways that could provide a solution. The other way is, of course, as you mentioned, and which is also one of the directions that we see here in Singapore, it's also subvention and subsidies for producing this kind of green hydrogen, which could be a short-term also solution that could be effective.
Okay, thank you. All right. So we next welcome our next speaker, Mr. Peter Goh, Vice President of Samsit Group. He will be sharing his presentation on innovative mini-grid projects to accelerate renewable deployment. So as a Vice President of Samsit Group, Peter oversees the group's energy efficiency and R&D arms. His areas of expertise in the green industry includes total building performance, energy performance contracting, energy auditing, and green roofs. Peter, over to you.
Thank you. A very good afternoon to all attendees. Thank you to the organizers and SPECS for inviting me to participate in this session. I'm Peter Goh from the Samsit Group. Today, I'll be talking about innovative microgrid projects to accelerate renewable deployment. Before we dive in, I'd like to share more about Samsit Group with everyone. We were established back in 2011, about 10 years old today, and we currently have over 2 gigawatt peak of solar capacity contracted across 11 countries. We are Singapore's most established clean energy solutions provider. We serve clients ranging from local small medium enterprises to large local corporates to multinationals and government organizations. We are supported by an extensive and robust network of financial institutions and business partners, including our shareholders, Temasek Holdings, Banpu, banks such as UOB, DBS, ING, and industry partners such as Baostep Projects. Since our inception in 2011, we've always been known to be a solar company. However, over the course of our company's growth, we have expanded to offer the full end-to-end range of clean energy solutions. And these include energy retail, clean energy retail. We provide clean energy to the likes of Apple, Google, Facebook, and Amazon, to businesses and homeowners. Energy efficiency solutions through energy performance contracting, whereby we finance and retrofit M&E equipment such as lighting and ACMV systems and co-share resultant cost savings with our client. Green roof solutions, EV charging solutions through our subsidiary Charge Plus. We do in-house R&D on the digitalization of energy by applying machine learning and artificial intelligence. And last but not least, energy storage systems and microgrids. ESS is an important element of the big sustainability picture. We believe that sustainability is multifaceted, not just about clean energy generation, but also about demand-side management and energy storage. We look at how we can integrate ESS with PV systems to form microgrids to improve energy resilience and reduce reliance on the main national grid. ESS also helps to manage the intermittency issue of solar PV systems. We started our ESS journey back in 2019 with the Punggol Distributed ESS project. As a contractor, we deployed a combined 100 kilowatt hours of ESS across 5 blocks at Punggol Waterway Estate. With the utility scale ESS in 2020, Sunseap was the principal investigator and deployed the 2.4 megawatt hour ESS system connected to a substation. In Q3 of 2021, we're looking to deploy a 1 megawatt ESS with 300 kilowatt peak of floating solar PV and ESS to form a microgrid to provide power to the jetty area of Pulau Ubin. And in Q4, this quarter, or perhaps early next year, we'll be deploying a near-shore floating 1 megawatt peak of solar with ESS at the southern tip of Singapore. Moving on to Singapore's first utility-scale ESS project, which we're very proud to be involved with. This project is jointly funded by EMA and SP. It is a 2.4 megawatt / 2.4 megawatt hour lithium-ion battery storage system connected at a 22 kV grid level. As the principal investigator, Sunseap is responsible for the installation and operation of the ESS. NTU, as the co-investigator, oversees the development of an ESS model to predict battery health and performance. This project is still ongoing and currently in the operational phase. I have listed down a few expected outcomes and learning points for today's sharing. Firstly, the development of a utility ESS model for state of charge and temperature prediction for fault diagnosis and risk assessment to see and understand the typical ESS performance in Singapore's hot and humid environment. Secondly, we want to optimize operational efficiency and offers into the electricity market of Singapore. This allows us and other operators to assess commercial feasibility of ESS in future deployments. Do note that the optimization portion was also covered in the Punggol Distributed ESS project, but it was purely a simulation. Lastly, we wish to identify and resolve regulatory requirements or overlaps or redundancies. Due to its nature as both a load and a generation source, there are multiple regulatory hurdles and deconflicting required between SCDF, SP, EMA, PSO, and EMC. We also had to clear BCA and NEA during our construction phase. So that's a mouthful of acronyms. It is thus very important for these knots to be untied before mass deployment in the very near future. So our system is about 3 months into operation. I will share some of our experience up to date, starting with the design stage. The very first challenge we faced was finding the land or space for the ESS. Now, Singapore is a small country. We are land scarce. Our original site location was at an open air sheltered space, as you can see on the right of the photo. However, this site was rejected as it was not completely exposed to the sky. So not only must there be unrestricted access to the fire engines, it must also be fully exposed. Thankfully, another site was made available to us, so that's where we are at right now. We understand that the decision was due to fire safety concerns, especially since this ESS is the first of its kind in Singapore, but there are really not so many substations that are completely exposed. And this ties in with optimizing the efficiency of the ESS. What do I mean by that? Utility scale ESS are most effective when connected to a node redeveloped when there is a need to provide grid support services that an ESS can provide. For example, a substation serving a district that's being redeveloped for industrial use. The substation might not have a piece of empty land for an ESS to be installed. So this is something that grid operators and regulators have to consider for future mass deployment, especially with an ambitious target of 200 megawatts by 2030. Next is regarding the fire rating of the battery container compartment. Our latest fire code introduced a maximum capacity of 600 kilowatt hours per compartment, which, based on our understanding, references the US standards, also known as NFPA 855. However, we also know that the NFPA allows exceeding this capacity if the system undergoes additional tests and risk analysis. For such safety concerns, not only can we refer to the US NFPA standards and local fire code, we now have a new guideline to reference to, and that is the TR77. Next is the HVAC or cooling and ventilation requirements for the battery container. And yes, there are ventilation requirements. So for cooling requirements, I think they're quite self-explanatory. Lithium-ion batteries need to be kept cool for safety measures to maintain its efficiency and prolong its operating lifespan. This is especially important in Singapore's hot and humid climate. Now on ventilation, currently our fire code requires battery rooms to have ventilation. The keyword here is rooms, which means that people can walk in to the battery container. So the battery container in this case is being treated like a space or a room that people can enter and work inside. We had an initial design which allowed walk-in access, similar to this example here on the far right, but this was quickly changed to a non-walk-in design where there are doors along the entire length of the container, if you refer to the picture on the bottom of the screen. And the battery racks can only be accessed from the outside. We think that this is a safer design for large outdoor systems moving forward. And we believe that this will also be preferred by the authorities as well over the walk-in version, as it carries less risk to the personnel. Next, on to the technical standards. We had issues on getting the PCS approved as there were no local standards, even though the PCS is a matured product with international standards. The reason behind these, quite technical, which has got to do with earthing and insulation. I won't go into the details here, but the gist of it is that local standards such as SS638 or CT5 do not cover the PCS, and local QPs and qualified persons are unfamiliar with this equipment and hence hesitant to endorse it. With the development of Singapore's TR77 standards that I mentioned earlier on, this will help to align the industry on which equipment is acceptable in the local context to smoothen future deployment. Moving on from design to installation and testing stage, the main issue we had during installation and testing was the lack of local contractors and QPs who had the expertise or the confidence to take up the work. A lot of hand-holding was needed from us, especially by our equipment suppliers. And we give a big shout out to our EPC partner for this project, which is Wärtsilä. We also faced some logistical issues due to COVID. So for example, we could not bring in any overseas experts so we had to do most of the guidance through video calls. And luckily, we were able to witness the FAT for the critical equipment before the pandemic. But there are solutions to these issues. Firstly, local expertise and capabilities need to be developed, perhaps by making training courses available and also through information from the TR77. Second, factory testing facilities should be made available locally, especially after the pandemic period. I believe that EPGC recently launched the test facility for ESS, so I think we are moving towards the right direction. Moving on to operation, before this ESS can even start discharging to the grid, there is a long list of registrations and licenses that we had to apply. This list basically is the same as what is required for a power plant, as the ESS is recognized as a generation facility. This process might be necessary for a power plant, but if the intention is for ESS to be more widespread, then these administrative processes need to be streamlined. Such processes also complicated by the fact that the ESS is being seen both as a load and a generation at the same time. Some expected operational costs for the system are transmission and grid charges, as well as monitoring, maintenance, and market participation costs. As for revenue, currently ESS can only provide regulation and maybe reserve, which based on last year's estimates per megawatt hour, is about $10, $12 to $20 for regulation, which if you think about it, really isn't much. So this is something that the industry and the regulators need to figure out. What are the services which will be in demand, and to establish market mechanisms for ESS to be commercially viable. For example, the ESS can defer upgrades in the grid infrastructure, so perhaps there should be a fixed fee paid to the operator throughout its lifespan. With all that being said, and the Singapore government clearly spelling out its near and mid-term green plans with solar and ESS amidst many others, here at Sunseap, we definitely wish to help facilitate widespread deployment and adoption and commercialization of ESS. Regulatory framework for ESS needs to be clearly defined. A separate category to represent ESS, as it is both a generator and a load, and to address the ESS limitation by differentiating them from conventional generators. Energy market will need to recognize and reward ESS for fast sub-second response. A separate grid support service category that remunerates ESS based on response time needs to be in place. As there is a lack of land space, distributed ESS and nanogrids and even floating ESS should be considered. And lastly, government subsidies for facilities to be installed behind the meter for purposes of peak shaving. With that, I come to the end of my presentation. Thank you, and I wish everyone a great day ahead.
All right, thank you, Peter, for the sharing. Thanks for sharing all your challenges in implementing the energy storage systems. So on that note, if someone were to be interested in joining this, become one of the ESS technicians or engineers, what kind of prerequisite should he have? What kind of...
Well, I think electrical background will definitely be helpful.
Yeah.
So whether a diploma or degree in electrical engineering, that will definitely help.
Besides that, do you think the person should go into having a fire safety kind of certifications?
I think it depends on which part of the value chain will this person want to be involved with. If it is something that is quite downstream, for example, ourselves as an owner-operator, the fire safety knowledge is important, but I think it's not a prerequisite because that is something that can be picked up on the job. So definitely useful to have, but I don't see as a deal breaker. Okay. The main thing you should have is interest and belief in ESS systems.
Right. So I noted that currently you're using batteries as a form of energy storage systems, but as we scale up to megawatt or gigawatt hours kind of operations, right? How would the use of battery, because prevalently it has a very low energy density itself. So yes, as we scale up, given that Singapore doesn't have a lot of land space, how do you see is it going to become a problem? Are you going to adopt other technologies to overcome this kind of problem?
I think definitely technology improvement will help the situation, but that takes time and a lot of R&D efforts. There are also different types of ESS technologies that are good for different types of applications and serve different functions. The way I see it is that in order for Singapore to reach the national target of 200 megawatt hours, it has to be distributed ESS that will form the majority of it. So instead of 40-foot container utility scale ESS, I think what we will likely see will be smaller, maybe 100, 200 kilowatt hour ESS system at the block level for HDB blocks, for example, or industrial buildings, for example.
So for you, do you see what are the upcoming technologies that could replace battery for this kind of applications?
Well, for us right now, we are exploring with flow batteries. For our upcoming Pulau Ubin microgrid project, we are using flow batteries because of its properties. It's able to provide long discharge as compared to lithium ion. And because we are not using it to participate in the energy market, the sub-second charge and discharge is not really critical to us. We needed something that is able to provide long discharge and also not so much of a fire hazard. So that is one thing that we're looking at. I came across solid state batteries recently. So that sounded very interesting to me, and I'm looking to see are we able to use that technology in some of our projects for us to better understand the pros and cons of the technology. But I believe that we shouldn't be too overly fixated on one single technology because it is not a magic bullet. In order for ESS to serve its function at a macro level, we must consider different types of ESS technologies across different areas serving different functions.
Okay, thank you. Thank you very much, Peter.
Thank you.
So next we have Chi Seng, who will be speaking on the electric vehicles and charging infrastructure. So Chi Seng is a product and pricing analyst from Komoko Motors. He has been in the automotive industry for almost 7 years, which has given him a lot of exposure on the advanced features of vehicles and the technologies and philosophies that drive the cars. So Chi Seng, when you're ready.
Hey, thank you, Dr. Ting. Hi, everyone. Good afternoon. Can everyone hear me?
Yes, we can.
Okay. So, yeah, I'm Chi Seng, working in Komoko. And let's move on. Being 7 years in this industry gave me a lot of exposure in the automotive world. So today I'm going to give everyone a quick general overview of EV infrastructures and charging infrastructure, EV vehicles and EV charging infrastructure in Singapore. So that's a quick introduction for my company, Komoko. We actually have 5 brands in Singapore, Hyundai being the most popular, common in among Singaporeans. And if we talk about electric vehicles, Hyundai, out of the 5 brands, will be the first one to introduce. Harley-Davidson, we are going to have, they have electric bikes. Hopefully will be introduced in Singapore soon. Jeep, not so much yet. Ferrari, there's a plug-in hybrid available already. Maserati is going into hybrid soon. So we are going to actually seeing brands moving on into more and more electrified vehicles.
Sorry, Chi Seng.
Yes.
Will you be able to share your slides?
Share. Oh, sorry, I didn't share my slides.
Yeah. Yes, we can see it now.
Okay, because I was looking at my slide, forgot to share. Okay, so yeah, these are my 5 brands: Hyundai, Harley-Davidson, Jeep, Ferrari, and Maserati. And we can actually observe, I actually observe that more and more brands are going to electrify their vehicles. And EV is going to be the future trend for in the global sense. And for Singapore, all this information that I've gathered here is actually searchable online. So I actually put all this reference together to give us a quick overview. And for Singapore, we're actually getting more and more serious into introducing EVs into Singapore. And the keyword here is that the government has been pushing to phase out ICE, internal combustion engine vehicles, which is the normal petrol engine vehicles. So which means in future, in the next few years, we'll be seeing more and more hybrids and electric vehicles. It's very important for the government to have a push because generally to own an EV is not that cheap. It's generally still expensive to own an EV. And another thing is the charging infrastructure in Singapore will determine how quick the people actually want to own electric vehicles in Singapore. So talking about charging infrastructures, so the government is also pushing for more and more industrial players to install more chargers in Singapore. Like what Sansi had mentioned previously, they are going to target to install more EV chargers in Singapore. It is part of the movement, the national target to achieve 40,000 charging points in public car parks by 2030. This is the target set by Singapore government. And they are looking to collaboration with a lot of industrial players to achieve this plan, this target. Currently, the charging infrastructures, we do have main players like SP, Singapore Powers, and Shell. The main thing about EV chargers is that we want it to charge fast. That means we are talking about at least a 50 kilowatt EV charger, which is a DC charging infrastructure. So SP actually have a lot of locations, 54 locations and more, and they are still expanding. Shell, they have installed in like 18 locations for their DC chargers, and they are going to expand into more as well. And not only DC charging, they also provide AC charging for public use. And just a quick cost information, SP is charging in general about 48.9 cents per kilowatt hour, and Shell is charging 55 cents per kilowatt hour. So what does it mean? This kind of cost, it means that when you translate to a normal, compared to a normal petrol engine vehicles, this cost for the same distance, we are actually talking about 50% cost saving in terms of the fuel cost. So we might be thinking, what about home charging? Home charging, it will be 25 cents per kilowatt hour. So if some EV owners, they are able to install AC chargers in their home, they actually can save up to 75% in terms of fuel cost saving. Okay, let's move on. So what defines electric vehicles? Electric vehicles, for pure electric vehicles, there won't be any engine. No petrol engine, no diesel engine. Purely just driven by electric motor. The main powertrain will be electric motor, and it's powered by a big high voltage battery underneath the vehicle. So actually, the base of the vehicle is all the high voltage battery. And usually, EV, we talk about charging, there will be two types. Singapore have adopted mainly the most common one, these two types will be type 2 AC charging and also a combo 2 DC charging. Singapore also allowed another type of fast DC charging, which is called the CharDemo, but not so common to be seen in Singapore yet. So if we talk about this DC charging, combo 2, which is all available on SP Power's charging infrastructures and also on Shell's charging infrastructures. These are the nationally more recognized charging types. And all our vehicles imported, not only our brand, all the brands in Singapore imported the EV vehicles will be using either the AC charging or the DC combo 2 charging type. So no worries, like if you are able to import or buy an EV in Singapore, surely there will be a charger suitable for you. So charging modes, what kind of charging modes can we observe in Singapore? Okay, before that, there are actually 4 types of charging. Mode 1 means that the car is actually connected to the power supply directly without any computer or control unit in between. mode 1 charging is not allowed in Singapore from the current charging standard and regulation, because they are deemed too unsafe. So because there's no control unit to control the current flowing between the cars and from the main power supply, is like there's a high possibility that they may be overheating if we are not too careful about it. Then for mode 2, at least from connecting from the car to the main power supply, there will be a control unit. This is not allowed for public charging, but for private, maybe you can consider using this. Then for the public chargers that we see outside, like SP and Shell, they are all using either mode 3 or mode 4. Mode 3, it means there's a fixed charger on the wall or on the platform, on the standee. The charger itself is actually fully controlled and regulated, that it passed all the safety requirement in order to deliver the electricity to the EVs. So mode 3 is actually using AC connecting, delivering the AC current to the car. Then for mode 4 is actually more for DC current to the car. And DC will be high power charging. Generally for AC, right, is ranging like 7.4 kilowatt or 22 kilowatt, this type of power charging. And for DC, usually it will be more common, 50 kilowatt or maybe 100 kilowatt charging. So how does it translate to time? A typical EV, like our Hyundai Ioniq, they have a battery of 38.3 kilowatt hour. So a 50 kilowatt charging station will actually be able to charge the car full in less than 1 hour. This kind of general comparison. Okay, recently, maybe some of you have heard of the latest ABB Terra 360 EV charger, who is actually able to make use of this high power 360 kilowatt. It's not a very low number, it's a very, very high number. And just a quick comparison. I put out 4 models that can actually support high power charging. Starting from the bottom, 150 kilowatt charging, DC charging, Polestar 2. Then go up to Tesla Model 3, the recent sensation, a lot of hoo-ha from the Singaporeans, because Tesla has been delivering a lot of cars in Singapore these 2 months. And this car can actually support up to 250 kilowatt DC charging. So it's not yet 360 kilowatt. Then Porsche Taycan, they can actually support 270 kilowatt. And our Hyundai Ioniq 5 can actually support 350 kilowatt. It's still 10 kilowatt away from the 360 kilowatt. So who is actually, this fast power is actually targeting who? It's actually targeting the more on the commercial side. Example, the bus. The bus actually can support up to like 450 kilowatt charging. That's a different level of playing field. So for normal passenger cars, at this moment, although we have the Ioniq 5 probably running in Singapore, but there is no such high power charging available in Singapore yet. The highest power should be around 150 kilowatt to 180 kilowatt somewhere in Singapore. Okay, so there's one more small point, adding 100 kilometers in less than 3 minutes. This one can be calculated because 360 kilowatt means in charging 1 hour means that in 1 minute you have 3 kilowatt hour. 3 minutes will be 18 kilowatt hour. So for normal EV cars to drive 100 kilometers, typically range from 15 kilowatt hour to 20 kilowatt hour. So basically, this charger can actually deliver that kind of power in 3 minutes. So which means, in other words, if the car can support such a high power charging, plugging into it in 3 minutes, you can go for another 100 kilometers. Okay, so now we're going on to EV models. In Singapore, we have a lot of EV models available already. And fortunately for Commercial, we are the first authorized distributor to be able to commercialize our first, Singapore's first EV in Singapore. We call it Hyundai Ioniq EV. And we also have introduced Kona EV the following year. Then actually, in terms of EV, we are not the first to introduce the EV lah. We do have like BYD Taxi, which first introduced in 2016. Then we have other models like Renault Zoe, Nissan Leaf, MG ZS, and one more, the new one, MG5. And we have other continental brands as well, like BMW i3, Jaguar I-Pace, Audi e-tron, Porsche Taycan, Mercedes EQC. And after EQC, there's also another Mercedes EQA, Mini Electric, BMW iX3, Tesla Model 3. So over the years, since 2018, when we first introduced our first Ioniq EV, up to now, we have more and more EV models coming in. And not to forget, we also have a car sharing under Blue SG. They are using the model called Blue Car, produced by Bolloré. So over the years, I see more and more brands bring in EVs. Being the first automotive brand to being the first company to bring in the EV means that we actually open up the doorway for the regulation to actually be able to accept the first commercialized vehicles. Then from there on, actually, it's easier for other brands to actually bring in the EV. Now, I think EV market in Singapore is getting more and more matured. So getting an EV into Singapore to run on the road should not be too difficult now. At this stage, Singapore is actually picking up. There are more and more EVs on the road, as we can see from this slide. As compared to the last year, if we look at this portion, we have 1,217 EVs in Singapore. As of August, which is August this year, we have actually increased 52% to 1,855 units already. Also to mention that in September, Tesla registered another 300 EV in Singapore. So the population of EV is actually getting more and more. And as such, it's more and more important that for the industrial players to install and also the government to push for more EV infrastructure to be installed in Singapore as well. So to push for more adoption of EV owners. And another point to define EV is that electric vehicles they are highly advanced vehicles, which means they have a lot of smart features. In Hyundai, we term it as Hyundai Smart Sense. Smart Sense in such a way that it prevents the car from collision. Like forward collision avoidance assist means that if the car suddenly brakes in front of you while driving, then if you are not able to brake it in time, the car is smart enough to help you apply the brake for you, so that you minimize or prevent. The best is to prevent the collision from the front vehicles. Blind spot collision. The next point is blind spot collision avoidance. That means the car is actually able to detect cars at your blind spot and give you a beep warning when you are trying to switch your lane, and so on. And we have a lot of other features. I don't think I want to go into the details on that. Then for EVs, is it very easy to run EV business in Singapore? Actually, not easy, because EVs are generally more expensive than normal ICE petrol vehicles. So companies need to invest more to build up their inventory. So we do have EV taxi business like HTT Singapore. They set up their business in a couple of years back. And unfortunately, because of the COVID-19, a lot of us have to stay at home. So this taxi business got affected greatly. and they have to close down, announced for close down last year, November. But is this the end? No, actually not. We do have another EV taxi business coming up. SMRT actually just bought 300 MG5. It's a China-made EV taxi, EV models. And as of August, we have 15 MG5 running on the road. I think as of last month, there should be about 75 vehicles, such taxis running on the road already. So don't be surprised that you see a green taxi with the word stripes running on the road. They're actually pure EV. And EVs, one of the main characteristics is that they are very, very quiet. They can creep up behind you without much sound because there's no engine running. And electric motors is very, very quiet. Okay, next slide. Let me introduce on the EV car sharing. Blue SG is, as it suggests, EV car sharing means that you can actually rent a car for like as short as half an hour, 1 hour, or even a few minutes just to do your day-to-day operation, like maybe to deliver some things or maybe to fetch your kids. So this is another way to have a car-like lifestyle. You don't have to own many cars. You don't have to own EV. You can actually rent an EV. So like maybe usage of EV for a normal person, maybe once a week, it could be a nice solution for such a lifestyle as compared to buying an EV and then drive it for every day. It depends on the lifestyle. Just a quick run through. Membership for Blue SG, $8 per month. Rental fee is 36 cents per minute. And Blue Charge is actually running the charging infrastructure for Blue SG. So it's charging at $1 per hour. So it's not too expensive to really experience an EV, if you want to say that. So as comparing to long-term ownership of EV, this could be another cost-saving solution. Okay, next slide. What about the bus, the public transport? The government actually announced that all their 5,800 buses to be electrified by 2040. Currently, we only have about 2% running on either electric or hybrid. And moving in a few years, there will be more and more such hybrid cars or even electric buses running on the road. And we do have actually 60 electric buses running on the road today, running by 3 different companies, 20 under BYD, 20 under Yutong, and 20 under a customized bus operated under ST. All these 60 electric buses are owned by LTA. So we can see that this is another example that government is taking serious steps to adopt EV vehicles in Singapore, not only for public usage, and not only for private usage, it's also for public transport. This slide is to say that one of the models for the EV bus, electric bus, it can actually do overhead charging, or we call it pantograph chargers. These chargers can actually supply 450 kilowatt charging. Then the rest of the EV buses will be charged using cable. Cable either 90 kilowatt charging or 150 kilowatt charging. Okay, going on to trucks. We do have EV trucks coming into Singapore as well. And this is actually operated under Sembcorp as a department, Semways. They want to adopt 24 electric trucks for their operation. So not only the government is pushing, even the private sectors, they also want to try and do some trials so that they can actually convert their normal diesel or petrol operation vehicles to fully electric or if not hybrid. Because this is the way that for future, we have the direction for the globally, this is the global direction that we are going to set. Then we talk about so many electric vehicles. What about hydrogen fuel cell vehicles? Hyundai actually have a model. Hyundai Nexo is a fully run by hydrogen. But is hydrogen actually a good way for today's market? Just a quick cost analysis. A normal ICE car can cost about 100,000 in today's price. Just to 100,000 can get you a normal ICE car to drive on the road. And this Hyundai Nexo, if you convert their high OMV into today's price, it could cost about the range of 400,000 just to drive this car. So if we talk about EV adoption is already expensive, then what hydrogen fuel cell vehicles will be even more expensive to adopt. And Singapore actually, the government has actually commissioned some company, KBR, to do a hydrogen study in Singapore. But they deem that hydrogen is actually not cost saving for normal petrol cars in Singapore. But they suggested that it may be suitable for commercial use like taxi, bus, and heavy goods vehicles because their operation requires the vehicle to run for a very, very long mileage, and that could justify for the high cost in hydrogen supply. But yet again, this will take some years to fulfill, as the cost for hydrogen is still very expensive. So in Singapore, it becomes like a chicken and egg thing. Do we want to bring in a fuel cell car in Singapore first, or we need to build up the hydrogen infrastructure first? Either way is very expensive. And it takes time for people to actually be able to adopt to the new technology. Okay, I've come to the last slide. Before we can, I received any questions from the ground. Actually, I asked some questions for myself as well. What is the expected lifespan of an EV battery? Actually, for EV battery, you can see in the market that the warranty terms for EV battery is actually 8 years. So for a normal COE means that a car can be driven in the Singapore road for 10 years, and giving consumers 8 years warranty for battery means that given a level of confidence that throughout the 10 years of ownership, at least 80% of the time they are covered. They don't have to worry about the EV batteries. So then the second question, does fast charging degrade the battery quicker? It's not because of the fast charging will degrade the battery. It's actually the heat generated through this technique will degenerate the battery quicker. As for fast charging, at least 50 kilowatt charging or 100 kilowatt charging, it will heat up the battery into a very high temperature. And as what previously Peter from Samsung actually mentioned, for lithium battery to be efficient, you need it to be cool. So if we keep on exposing this the battery in the EV to be high temperature for long period of time, it will definitely shorten the lifespan for the battery. But that's why we have always pitched to customers that when you do DC charging, try to stop at 80%. Charge from whatever state. When you charge until 80%, actually you can stop and you can go 80. You don't have to charge to full. Because any charging beyond 80% will subject the battery to a longer period of heating. And another point is that after 80%, the chargers and the car actually will try to moderate the charging to be slower. So like 50 kilowatt charging, after 80%, the car will actually charge at a lower rate, like maybe 30 kilowatt charging, or maybe low as 20 kilowatt charging or 10 kilowatt charging. As it approaches more and more nearer to 100% full charge, the charging rate actually will decreases. So the charging time will be extended. The full up to 80% is all the fast charging. So up to 80%, the vehicle can actually experience the full capacity of the 50 kilowatt charging in a way. So that's why we usually recommend customers to start at 80%, and they can actually went around maybe until down to 30%, 20%, then they can actually charge the car again. Don't have to always keep the battery to 100%. That's the message that we want to pass through. Point 3, what is the expected value for second-hand vehicle? Second-hand EV electric vehicles. This has to boil down to the scrap value. As a normal car, we talk about the par value. Par value is based on, at the end of near 10 years, when we want to deregister our car, to scrap the car, the par value is actually 50% of the ARF. As for EV, we have vehicle emission scheme that allows EV to enjoy up to $25,000 rebate. And from this year, January onwards, EV also have another early EV adoption incentive, which can give a rebate of up to 20,000. So altogether it will be 45,000 reduction on the ARF. So in this way, your par value is greatly reduced by the rebates from the upfront payment. So if you want to say that after 10 years, if you want to buy a second-hand EV, probably will be slightly cheaper than the normal ICE in this way. Is there a business case for battery swapping? We can see battery swapping a lot of example from China market, but I think in Singapore we do not have such a high volume of EV. So I don't think that battery swapping will be feasible in Singapore, or we won't be able to see such a business case in Singapore yet at this moment, until we can hit a high volume of EV. And example, taxi operation or bus operation is so matured that 2-hour charging or 5-hour charging is too slow for the operation, and we need battery swapping. Then maybe we'll see more and more people coming in to build this business case. Last point, is it more dangerous to own an EV due to fire hazard? Actually, all the cars in Singapore, or particularly for Hyundai EV, all the vehicles from Hyundai actually pass all the safety regulation. All the cars actually had to run through crash tests, IHS safety plus Euro CAP 5-star safety. So in order to pass all this, the car itself actually have to uphold a certain level of safety. And after crash, the battery doesn't catch fire, doesn't explode. So this gives a level of confidence to the manufacturers and the consumers, that owning an EV actually is as safe as owning a ICE vehicles. So as long as we take note, like don't casually expose the car to unnecessary high heat. As with ICE cars, if you expose the high heat, the battery inside will also subject to high temperature and maybe risk of fire hazard. It's actually similar. The level of safety is actually similar for ICE cars and EV. So there's no, and globally EVs is relatively still new. So we cannot really judge that EV is less or more safe than ICE at this moment. I personally think that as long as the car has passed all the safety regulation, it should be safe to own and drive and be driven on the road lah. Yeah, and Singapore we have so many safety measures. Usually no issue for this. Okay, I think I've done the slides.
Thank you, Jason, for sharing the status and also analyzing the landscape of the EV vehicles. Probably just a quick one. So it seems that the BEVs are going to be the mainstream, but is Singapore and the car owners ready for the transition?
Singapore and EV car owners ready for transition. I think it's actually, in a way, is convenience and price driven. EVs are actually nice to drive. People who drive EV will tend to say that it's actually very exciting to drive. And mostly when the customer feedback to us is that EV a bit more expensive. Maybe I drive a ICE car to be easier for my day-to-day operation. So if one day EVs can be as cheap as normal ICE cars, I think consumers will be more than willing to quickly switch over to EV.
Okay. I think actually I got a question from a personal friend who just texted me. He was asking about whether the Tesla is able to be charged using other charging stations.
Sure, I don't think Tesla, the vehicle itself, is actually restricted itself to be charged only by its Tesla charger. But I heard that Tesla chargers, they only recognize Tesla cars. So my Hyundai cars, if I want to drive to a Tesla charger, I cannot use their charger. But Tesla car, not only they can use their Tesla chargers, they can use all the SP chargers, Shell chargers. It's no issue.
Okay, thank you. So we'll move on to the next speaker. Next, we have Raj Kumar, founder and group CEO of IGSS Ventures, who will be sharing on the powering Singapore's niche tech commercialization opportunities with the best of silicon and compound. So Raj has 30 years of experience in semicon industries. He currently leads IGSS Ventures Group, a technology investment holding company with subsidiaries focused on two core segments. One is on the foundry transformation services, and the other is on the commercialization activities in the niche emerging semiconductor techs, spanning gallium nitride and silicon photonics. Raj, when you're ready, please share your slides and you can go ahead.
Thank you, Dr. Ding. Hello.
Raj, you might want to run without your speakers.
Yeah, just give us a... Can I just use this?
Hello, can you hear?
Okay, can you hear me now?
Yes, it's good.
Okay. A very good afternoon to all, and I'd like to thank A-Star for organizing this webinar. My topic today is Business Unusual, Singapore's commercialization opportunities in power conversion technologies. I think one of the key differentiators we bring to the table is we're very much in deep technology, very much in upstream, in the front end, okay? And let me go to the next slide. Okay, I will start off the presentation with how to enable a promising future for Singapore. Okay, this is a very important question. And then moving on further into gallium nitride, okay, a key technology and material for power electronics, for EVs, and also other specific power applications and RF applications. Okay, and I'd like to end the presentation with how IGSS Ventures Group and our subsidiaries, the role that we can play in these emerging niche technologies in Singapore. So what will a promising future look like for Singapore? Before we answer this question, let's just have a recap, okay, of Singapore's strengths and gaps, right? We are definitely a first-class nation with world-class infrastructure. We are quite attractive for global talents to live, work, and play in Singapore. We are pioneering semiconductor, especially in semiconductor fabs and fabrication technologies. We were one of the first nations that started with semiconductor foundries in 1985-86. The gaps, end of the day, we are a red dot, okay? A nation with limited domestic markets and limited talent or manpower, right? And also limited semiconductor investors in Singapore compared to any other competing semiconductor nations in the world, right? So we aim to establish a Singapore gallium nitride nexus. We also do other emerging niche technologies, but today, in the interest of the topic, power electronics, gallium nitride is a very relevant material for this. There are 7 key steps that we are embarking on. The very first and the most important, when we first started gallium nitride on silicon in iGaN, one of the key subsidiaries we have, there was no ecosystem in Singapore, meaning there was no suppliers, there was no vendors in Singapore for gallium nitride. So the very first thing we managed to do just in the last 2 years is to attract one of the top 3 MOCVD makers in the world to set up a shop in Singapore to support us technically on the hardware and also on the engineering part of it. Okay, so that was done. And moving forward, we want to position Singapore with relevant partners in Singapore and overseas as a GaN innovation incubator in gallium nitride and also perhaps in silicon carbide, right? And it is important to establish Singapore's differentiators in these emerging niche technologies. And that will include from deep technologies, the space that we play into creating or enabling Singapore to become one of the few global hubs for EVs, to fully implement EVs, for example, okay? Or even in terms of power electronics in other segments. We also need to play a key role in developing local talent in these niche emerging technologies. So this is one of the challenges we have been facing for the last 7 years. Okay, most of our key technologies, most of them, not all, but most of them are basically from overseas, right? So that's something that we want to change in the Singapore landscape in the next 5 to 10 years time. Okay. And step 5 and 6 basically is to convert from innovation hubs to full production and R&D facilities that can support both global needs and Singapore's needs. Okay, so those are the 6 key steps that we aim to take. Why is this niche emerging technologies like gallium nitride or silicon carbide, why are these important sectors for Singapore to consider? Firstly, by 2029, okay, the market for GaN on silicon and silicon carbide will be $5 billion market. So that's almost double growth every year. Secondly, the point we need to consider when we look at the digital technologies like silicon, where we first set up shops in terms of wafer fabs and etc. in Singapore in 1985-86 onwards. Today, when we take a snapshot on silicon technology, we are easily 10 to 15 years behind global leaders. But when it comes to niche emerging technologies, specifically in gallium nitride, silicon photonics, or even perhaps silicon carbide, we still have a role to become a global player. Okay, this slide gives you the market SAM for both gallium nitride and silicon carbide. Okay, as mentioned earlier, 2029, it's a $5 billion market. If you look at the applications, it goes across multiple key segments. But let's not be mistaken that silicon is going to continue to be a dominant semiconductor material and technology for many segments. But when it comes to power electronics, when it comes to EVs, when it comes to next generation applications, etc., wide bandgap technologies like gallium nitride on silicon, silicon carbide has an important role to play. Okay, so this is where, for example, in power electronics, silicon has certain limitations. So there's a couple of key features in gallium nitride on silicon that makes it very attractive for power electronics. Firstly, it has a very small footprint, apple to apple comparison with silicon silicon chips. Okay, the footprint can be 50% smaller, can even go as high as 75% smaller. At the system level, it gives a lower cost. Okay, gallium nitride on silicon with specific epi growing techniques can also create quantum sensing capabilities. Okay, at the system level, again, the total components are reduced, which reduces again footprint and cost. And importantly, the performance of GaN on silicon for specific markets is far superior to silicon in terms of power efficiency, okay, in terms of switching loss and etc. So the key industries and segments that will be using gallium nitride and some of these wide bandgap technologies comprises from consumer electronics, from charging, okay, adapters, from renewables to power efficiency systems, transportation, electric vehicles, hybrid cars, 5G, infrastructure, and even biosensors. So what are Singapore's opportunities in this next generation niche technologies? As mentioned, these technologies, even though the R&D has been going on, the research and development has been going on for about 15 to 20 years, okay, including in Singapore and in specific top nations in the world like US, Japan, etc. The commercialization opportunities has just begun, right? So hence, because the R&D takes a very long time, especially the research, this creates a situation where even the largest and top technology players or foundry players in the world, like TSMC, Global Foundries, etc., they struggle to invest that much of time and funds into the research. Okay, so this is the space where top global R&D entities like IMEC, A*STAR, top universities, including NTU, who have invested that 10, 15 years in some of these technologies. Okay, so as a result, okay, when we came out from my past life, when I came out from a top foundry, okay, it was very clear that our business mission and company mission was to focus on emerging niche technologies where we can compete with the world's largest and top. Okay, so we partnered A*STAR, NTU, and also global experts around the world, right? So the number of entities today who can provide gallium nitride on silicon capabilities are very limited. So this gives us an opportunity for both us and Singapore players to become a global champion in these specific technologies. Okay, this slide gives you an overview of IGSS Ventures, which is the holding company. Okay, we have three key important subsidiaries. IGSS is the very first company that was formed. IGSS basically focuses on fab transformation. Okay, and we were also the innovator of a build, operate, manage, transfer fab model. Okay, where we are working with a specific top nation in trying to enable a semiconductor ecosystem for them. Okay. In a nutshell, these three key subsidiaries complement and enables us to participate in bigger things. Okay, IGAN, the second subsidiary that was formed, as the name denotes, fully focuses on gallium nitride technologies, be it gallium nitride on silicon, and also we have started working on gallium nitride on silicon carbide. Compound Tech, okay, is the youngest technology company we have in IGSS Ventures. It's one of the elite players in silicon photonics, where we are serving more than 20 commercial entities around the world. Okay, and separately, we also serve like 21 universities and research institutes around the world. Okay, so and one of the next key milestones for Compound Tech, we actually offer in silicon photonics all the way from process design kit, design IPs, all the way to fabrication technologies and testing capabilities. today, even though we are relatively small, okay, we play a critical role in the ecosystem, especially for the specific emerging niche technologies. Okay, so we basically play an important role from lab to fab. Today, we have 2 clean rooms in Singapore, okay, small clean rooms, but doing very strategic stuff in gallium nitride and silicon photonics. And if you look at the whole supply chain today for our customers, we provide some of the most important blocks from R&D to design support and importantly, the fabrication technologies. Some of the key elements in the supply chain is done by our strategic partners, okay, through exclusivity in some cases, okay. So this is creating a key value for our customers in the industry. Basically, the challenges that IGSS Ventures is addressing is twofold. One, if you look at it, okay, the multi-billion-dollar foundries around the world, they have the billion-dollar assets, but they do not possess a deep process knowledge on these emerging niche technologies. For the problem that I formulated earlier, the research part takes very long, even for the largest commercial players, right? So they do not have the deep process know-how, okay, and they also struggle with the need to focus on some of these technologies because they typically support the industry on multiple mass production CMOS technologies, right? So that's one of the key problems we are solving for customers and entities that requires a supplier for these emerging niche technologies. The second element is if you analyze the players in the power industry, it is dominated by IDMs, integrated device manufacturers, who are basically vertical players, meaning they basically have their fabs, their assets to support their own needs. They are not keen, or it's not their business model to support fabulous entities around the world, or even support other IDMs who requires these emerging niche technologies. So these are the 2 key gaps that we are addressing for the industry in these emerging niche markets. If you look at silicon, you do not have this problem, right? There's more than 30, 40 foundries worldwide who are more than happy to service the needs of fabulous and everyone. But when it comes to niche emerging technologies, there's a limited number of suppliers today. So our winning formula, if you might have figured it out, our winning formula, okay, basically is for these niche emerging technologies, we partner strategic R&D houses, the top R&D houses, both locally and also overseas, right? So we come in at the final stages of development. So the research is done by our partners. We come in at the final stages of development, and we put in a lot of focus to enable cost-effective solutions for initial production and mass production. That's the area. The latter is the area where we are strong in because we come from a mass production background. Okay, that's also very familiar with developing technologies from the beginning stage all the way to mass production. This slide gives you an overview of iGaN's journey since 2014 to now. Actually, in my past life, I had the good fortune to launch gallium nitride on silicon in a top foundry. That was in 2011. And when I, together with my teams, when we started our own companies in 2013 onwards, iGaN was started in 2014. We had a good opportunity to partner A-Star, okay, and NTU, and also global experts overseas, okay, where IPs from A-Star, okay, were out there to be licensed by a qualified entity like ourselves. So we took those IPs and we did more with those IPs than anybody else. Today we have our own IPs, okay, across the whole group. We have close to about 100 IP filings and know-how, both in gallium nitride and silicon photonics, okay. Today, each of the members in the technology members in the group have easily 25 years of expertise in a given field, okay. We are serving in gallium nitride, we are serving close to about 18 global customers at the early stage in sampling and prototypes, okay, both on epi and wafer fabrication, because we were the first to offer a one-stop solution, okay, on 8-inch in the world, okay, where we offer both 8-inch epi, gallium nitride on silicon epi, which is the rocket science of the technology, and GaN dedicated fabrication technologies, which is CMOS friendly, meaning our technologies can run in a CMOS fab. And like I said, okay, the very important seed to all these accomplishments was the 15 years of research work done by our technology partners. So we have achieved multiple technology milestones in gallium nitride, and the next slide will share more of this. One of our most recent breakthrough, okay, and this is one of Global's first, arguably the first, okay, but I'll explain that a bit more. One of Global's first to achieve 1000 to 1200 watts breakdown, vertical breakdown, okay, using cost-effective silicon substrate. There may be another 1 or 2 players in the world who have recently announced that they can do 1000 to 1200 watts, but they are using a very expensive silicon substrate, which is almost 5 to 9 times the cost of the silicon substrate that we're using. So our performance of 1000 to 1200 watts, which needs to be fine-tuned further, is achieved on a silicon substrate that only will cost us about $70 to $80, while other global champions are using pretty expensive substrate, which will cost about $500 to $1,000. Okay. The second key accomplishment we achieved recently, okay, on 650 watts, which is the benchmark for gallium nitride on silicon across the industry. Okay, automotive applications require 650 watts. Okay, if you look at the 4 key parameters, which is device performance, okay, we made a comparison between gallium nitride silicon epi wafers that is grown by iGaN versus one of the top epi growers in the world. I will not, okay, mention the name, but they're one of the top global epi providers. Our performance at device level, that means the fabrication technology was the same, and we came out with much better device performance, okay, which is very important. So this is my last slide, okay. So ITSS Ventures' aim is to, our vision is basically to become global champions in these chosen, selective, emerging niche technologies. And we basically have 3 key steps to achieve this vision. Firstly, okay, we are now moving from lab into R&D facilities, which is our own R&D facilities in some cases, into trying to set up the first production facility in Singapore. Okay, and the very first production facility we want to set up by Q1 2022 in Singapore is a production and joint lab facility on gallium nitride on silicon and also gallium nitride on silicon carbide. This has actually been delayed by a year, mainly due to supply chain issues due to the pandemic. Okay, and right now, okay, we are relatively confident that we'll be able to start executing this facility in Q1 2022. This will support global GaN epi commercial needs on both power and RF. Apart from supporting production needs, we are also looking to have a joint lab, both for our needs and our partners' needs, both for Singapore entities and global entities, okay, to enable the next milestones on this technology. For example, okay, RF, worldwide today, okay, gallium nitride on silicon, RF wafers is done at 4-inch and 6-inch wafer dimension. Our goal is to achieve 8-inch performance and breakthrough by 2022. We also have plans to work on 12-inch GaN on silicon, okay, that will be more like in 2023 onwards, okay. The second key step to realize this vision of becoming global champions, we started our business model using a lot of hybrid models, okay, which enables us to compete in a space that typically requires hundreds of millions of dollars or even billions of dollars. We have managed to reduce that to a fraction due to our business models and collaborations. And even though we have done that extensively in the last 8 years, the reality is there's still more opportunities for collaboration, both within in Singapore and also globally. Okay, so we intend to continue to enhance our collaborations with the top universities in Singapore and overseas, okay, with research institutes, with MNCs, with SMEs, and very, very importantly, with investors, with the right investors, okay, because one of the challenges we do face in Singapore, okay, in this region is there's very limited investors who are semiconductor savvy, okay, who are semiconductor savvy and who are keen to participate in this industry, which is a problem that needs to be addressed, because if you look at the whole world today, the so-called trade war is actually a technology war. Okay. And step 3 is our mission is to continue to create win-win partnerships globally. This is a model, this is a mission that we firmly believe in. Okay. And we are nimble, we are small, and by having win-win partnerships, we're able to do much bigger things. And I truly believe that Singapore has an opportunity, even today, to be a showcase, to be one of the global champions in optimizing public-private partnerships, with the end game being commercial and technology breakthrough success. If you have looked at the last 30 years in Singapore, especially in these emerging niche technologies, be it gallium nitride, silicon carbide, silicon photonics, the research institutes in Singapore, the top universities in Singapore have done an excellent job in publishing IPs and papers. But as a nation, we have done a poor job in terms of commercializing these capabilities into huge successes. And if you look around, there's multiple facilities in Singapore, okay, in the universities, in the research institutes, that perhaps we are optimizing only at 20% level, because they are not optimized for public-private partnerships to the scale that I'm talking about. And this scale is not a dream. It has been done in South Korea, it's been done in Japan, it's been done in Europe, it's been done in US. So we do have an opportunity to optimize these public-private partnerships, so we can enable commercial and technology breakthroughs that contributes end of the day to Singapore's GDP, right? So, and this becomes even more critical now in the current global technology war. You can see every nation, right from the top superpowers to every semiconductor nation, South Korea, Japan, Taiwan, some of the top European nations, not to mention about China and US, who are the leaders in terms of investments and the industry, especially US, okay? It is time, okay? It is time to create local semiconductor champions, because the long-term vision of Singapore, if you're going to be successful in the semiconductor space, we got to have local champions. That's one key differentiator we are lacking in today when we compare Singapore with any other semiconductor top nations in the world. Okay, so with that, I have completed my presentation. Thank you for your patience and time.
Yeah, thanks, Raj. Seems to be a very exciting time to be in the semiconductor industries.
Yes.
All right, I have a question which is on the technology itself. So how does the Canadian nitride power added efficiencies, linearity, noise, and the gate leakage compare with the best in class, current best in class right now?
When you say best in class, you are comparing with other material technologies, yes, like, yes, or with silicon, etc. Is that what you're saying?
Silicon.
Comparing with silicon, okay. I will not be able to answer all the parts, but the power switching and the power efficiencies is at least about 5 to 7% better, okay. What is important is that at the very high breakdowns or high temperatures, okay, the size of a silicon chip and a silicon system is very bulky, right? So if you look at EVs today, for example, close to 50% of the total weight of the EVs is basically in the power management system, in the battery management system. So when you start using wide bandgap materials, be it GaN or silicon carbide, you are able to reduce that significantly, more than half, right? So that is one of the key features of using gallium nitride on silicon, right? If you go to consumer electronics, for example, right? Okay, today, if you're using, if you look at consumer electronics, for example, okay, if you look at the charging systems that we used to use previously, okay, if you have a notebook, you have a mobile phone, you have your wife's notebook, you bring 3 chargers. Today, you have chargers that's the size of a lipstick that is made from gallium nitride or silicon carbide, okay, size of a lipstick that's able to charge all these 3 things, right? So performance is superior, okay, when you need to go into higher voltages or higher temperatures, okay, you need to have a better efficiency system and so on.
Thank you, Raj. So let us move on to the next speaker. We have Benjamin So, Managing Director of Hashtags, who will be talking on the blockchain bridging green projects and financial services. So Benjamin is a fintech leader who previously founded a multinational regulated B2B fintech firm serving the needs of more than 100 financial services firms worldwide with a focus on fintech, blockchain, and information security sectors. So he's now back in full-time doing the entrepreneurial activities with a call to enable financial industry on the B2B level with Stacks. So Benjamin, over to you.
Thank you very much and good afternoon, everyone. Thanks for having me. Thanks to Specs for having us. So today my topic will be about blockchain bridging green projects and financial services. So very excited to be here because I've listened to many of these wonderful green projects throughout the entire day. And, and all of these projects are really very involved in the use of better technology, cleaner energy, etc. And I would say that my business would be from the other side, because we are actually working with financial services, working with financial institutions, and hence I think that this topic will be quite interesting because we are actually talking about how we could provide a platform that will be the nexus between such green projects and the financial services. And of course, the technology that we use, blockchain, is also very interesting because just this afternoon, we also witnessed the signing of the MOU between the Blockchain Association and NTU. And of course, we are also part of the Blockchain Association. So that's where we see a lot of common synergies, going forward. Okay, so diving in. Okay, so a little bit about ourselves first. Okay, so why are we representing the financial industry? Why are we working so closely with the financial sector? Is because we are really from the industry. So many members of the team are actually from the financial industry. So if you look at my senior leadership, for example, my chairman, he was the Ray Ferguson, he was the ex-CEO of Standard Chartered Bank, and he is also now the current chairman of Aviva Singlife. So was a banker, now an insurance company provider. Okay, and I'm also many other members of the team from the capital markets. I was always been in fintech, and we believe in using technology to enable better society. Okay, so now that there's so many clean energy projects, green projects, how could we use technology to now create nexus to the financial industry? Okay, so we have experience working with many financial institutions. Okay, so these are some of our public accolades from our clients, and also we have won some awards for our work. Quite notably, we also won the MAS Global FinTech Innovation Challenge in 2020. So that was in the theme of sustainability and green finance. So we won in the Singapore category, and that has allowed us to continue to do more work in sustainability, when it comes to providing this registry. So the need for blockchain, in bridging green projects and financial services, I think everybody can see that the energy sector is a large component, of the global greenhouse gas emissions globally. So energy sector is one of the largest sector when it comes to greenhouse gas, and definitely there's been a lot of attention and a lot of work to move towards greener energy, cleaner solutions. So this is great. However, there are some pain points, especially when it comes to bridging this sector to the financial services. Okay, so as we got on this journey, we have spoken to many institutions, many corporates. So corporates are telling us, various sectors, they're telling us that there is still a lack of financing, and there's statistics from the United Nations. It states that there is a $2.5 trillion gap every single year, to finance enough, to be able to achieve our climate goals. In fact, I think this week, because there's a lot of more newer information this week, and of course next week, at the COP26. So I think the number has gone up right now. This 2.5 trillion was from a year back. I think just this morning I was reading a Straits Times. I think the number is now 6 trillion every single year. Okay, so that's where you see that in order to meet our climate goals, more capital needs to be put in, for such projects. Okay, and so that is one problem. And for a lot of corporates that I speak to, particularly the medium size or the smaller size corporates, getting certified is expensive, it's inconvenient. There's just simply too many manual processes, lack of manpower, lack of new technology to ease certification. Because at the end of the day, a lot of financial institutions, they need something like a certificate to be able to assure them to extend such capital. And today, to get some form of certification is usually too long of a manual process. So from the other side, the financial institutions will be worried about greenwashing. They are worried that projects claim that their projects are greener than they are. Okay, and thus it causes hesitancy. And a lot of data today are fragmented. They are not real time. They are in pools of isolated data. Okay, and they have very bespoke methods of data processing. Hence, very hard to track the end-to-end carbon emissions. So these are the various problem statements that were brought to us, and hence we felt that the use of technology could be able to enable, okay, and empower us to be able to overcome them. Okay, so what we really wanted to do is to provide a solution built on the blockchain technology, where if we imagine what does good look like, right? So imagining 10 years down the road in 2031, we have achieved our targets for 2030. Okay, the Singapore Green Plan is a success, right? So if we imagine at the time, what does good look like? We imagine that the future where a good society is where there is a common ESG registry. There is a digital registry where different components of industry, from energy sector, transport sector, building sector, agriculture, etc. Various sectors are putting information into a common registry such that financial institutions, when they want to quantify end-to-end carbon emissions, when they want to invest in a company, when they want to extend financing, they are able to retrieve insights. Okay, and with the use of blockchain, of course, we could digitalize it. We could, of course, create smart contracts. We could create, programmable conditions to be able to enhance these financial products. Okay, so if we zoom further into this ESG registry that is built on our blockchain, okay, what does it really entail? Firstly, digitalization of data. Many of this information today, be it your certificate from the BCA or your certificate from another certification body, these are usually non-digital. That means they could give you a scanned certificate, or you could retrieve some information from the website, but it's really electronic and not digital. What if we could ingest all of these certifications into one single registry? At the same time, okay, while we ingest these certifications, we also want to continue to retrieve raw data from the sectors. So we need to work with sectorial platforms here to retrieve data that would be digitalizing certifications and records that are digitally native. Now, this digitalized data will become portable, easier to standardize because it's digital from day one, okay, and programmable for financial products or even carbon credits or RECs. Okay, so these must also be available by API, okay, to other institutions, okay, and must be able to be reported in standard protocols, okay, according to industry standards that financial institutions expect to see. So with that in mind, financial institutions, banks, insurance, asset managers, institutional investors, they will now be able to, okay, target a real-time scope 1 to 3 emissions tracking, okay, sustainability linked financial products, tokenized, okay, high quality carbon credits using the blockchain. So as you can see by now, it's not just a blockchain doing everything. Okay, when we talk about retrieving data from the sector, it's just not the blockchain, it's also more than that. So we really have, luckily for us, a good panel of partners. We have partners in the IoT technology space, we have partners in the data analytics space. While we provide the blockchain ledger, we also have partners from the certification body space to be able to complete this end-to-end solution, whereby, where we collect raw data from the project. It could be a clean energy project, it could be a transition energy project. Okay, we are able to retrieve this data, have it processed with analytics, comparing it against standards, okay, so that certifier can be able to attest and certify it. And the blockchain allows for continuous reporting that financial institutions will be happy to accept. So the user journey looks like this. There could be an energy project or a manufacturing plant or even a building with energy usage and water usage being measured. Okay, some part of it is power grid, some part of it is solar. Okay, whatever it is, okay, we want to have all this data acquired. Okay, so real-time data acquisition of this data could be on IoT or drones, and inputting of sector-specific certification. So two types of data: ongoing data, static certificates. Okay, such that these are now compared against standards. And if there were to be a carbon credit, okay, we could also calculate carbon emissions. Okay, so that's what we have already done. Integrated with data analytics platform, decarbonization platform with one of our partners, for example, okay, who are already reporting this in various type of industry standards, okay, and calculating carbon emissions, okay, from end to end. So all these are our partner screenshots that are able to then send information to the certification providers to upload that into our blockchain registry. So on this green registry, okay, we are then able to retrieve this data, okay, interact with smart contracts for financial products, and also sell carbon credits if the use case allows us to. Okay, so that's where the output is. Financial institutions will then be able to have more enhanced sustainable finance, okay, and also be able to generate carbon if they are allowed to. So that's why the blockchain's reporting center will be able to be a single source of truth, is immutable, and the financial sector will be able to retrieve this at any time. So how do we unlock massive value? Okay, so this is the last slide in conclusion, okay, whereby, you know, corporates of any sector, right? Okay, we hear that many corporates, they are still, they started in the journey to sustainability, but just simply too many moving parts and too much manual work. Now, we hope to be able to allow them to easily access better green and sustainable financial services. So as a company, we have already started working with a few banks and asset managers. They are engaging us right now in our platform. So they are very happy to actually extend these sustainability linked loans or bonds, or even some of the asset managers that we are talking to, they are also quite happy to see how these corporates that can become more investable could actually now, okay, use this data that we are collecting, okay, to enable them to have these services. Right. So for many of these corporates, okay, they could also now start to enjoy automated carbon footprint emissions. They could also now start to enjoy, okay, the easier way to get a sustainability report, okay, through, okay, this end-to-end solution with our partners. And then actually when they are able to do so, okay, they are doing this, okay, and they are also having a clear picture of how to reduce, okay, their greenhouse gas emissions. Okay, so some of the corporates that are already on our platform, they are also able to see how, okay, from a strategy perspective, where to target improvement, how to reduce emissions, how to improve their sustainability score that will help them be able to bid for the next global MNC job, that will be able to help them bid for the next government job. Because let's face it, in the near term, okay, all corporates have to show some form of sustainability ranking in order to be able to get these, okay, larger jobs, because that's the minimum expectation, okay, of the world going forward. Now, from a financial institutions perspective, these are investors, these are banks, these are insurance companies. They are now more comfortable and assured, okay, to be able to have a continuous transparency, okay, on such investments. They are now more assured that when they deploy a green loan, it is really green. And because they do have to answer to their investors, many of these institutions are telling me that they have become a steward for their clients. So their clients are investors, okay, in their bank or in their financial products. They expect the banks or the financial institutions to act as a steward for sustainability. So this will therefore allow them to have ongoing data, okay, such that they will be more informed to make more investments. Ultimately, we think that with this type of a technology nexus, we will be able to drive enhanced sustainable finance with more financing, better investments, more insurance in a better data-driven technology way, and of course to be able to drive carbon credits that are highly portable and of high quality, because you can track all the way back to the project, okay, on the blockchain. So that's the end of my sharing. Thank you very much.
Thank you, Benjamin. All right. I think we have a few questions on hand. So one of which is related to the energy intensity tied to cryptocurrencies. So we all know that Elon Musk actually said he actually didn't want to invest in the cryptocurrency anymore because cryptocurrency is very energy intensive.
Yeah.
So is your hashtag blockchain equally energy intensive as well, or are there any steps to do any to drive down these energy consumptions?
I'm glad somebody asked that question, because the answer is, yeah, we are definitely not a cryptocurrency blockchain. Okay, so yes, cryptocurrency blockchains are usually energy intensive because there is this thing called mining, where they are trying to compete with each other to earn that crypto coin. So in our blockchain implementation, it is an enterprise grade blockchain implementation. There is no mining, there's no crypto involved, unfortunately. So we make very little money as opposed to them. Okay, but okay, our enterprise implementation also means that our blockchain can be hosted on normal, okay, AWS cloud servers, for example. So it doesn't add additional footprint. It is still a technology after all. It's still a server and data center after all, but it doesn't add to your current footprint. You don't need to have a specific data intensive or energy intensive usage here. Yeah.
Okay. So what is the vulnerability of green financial services with underpinning blockchain technology? Where research can help in this case?
Yep. So actually many financial services institutions, providers, they are already now using blockchain in a lot of their financial use cases already. Right? I mean, that's why we were started in the first place. 2 years ago, we were started to provide blockchain solutions for banks, financial institutions, asset managers. These are our clients. So the use of blockchain actually encourages greater transparency, immutability, a single source of truth, and the use of blockchain also allows for automation and programmability of smart contracts. So programmability of financial instruments. I mean, even the MAS is, it is quite well known that we are multiple projects in Singapore about digital money. Yeah, so that's where money can be programmable. Okay, of course, all of these projects have this very basic underlying fundamental proposition first. They are using enterprise-grade technology, so in a sustainable form. Yeah, rather than the cryptocurrencies that we are familiar with.
So there's actually no gaps to be addressed.
The knowledge or acceptance of such technology is already very well regarded in the financial sector. So financial institutions definitely are accepting this technology. Okay, it's really use case driven. So banks definitely do not like cryptocurrencies because there's an issue of money laundering, etc., right? So rightly or wrongly, that's a different matter. But this is nothing to do with crypto. This is entirely enterprise grade use case, and that's been widely accepted in various financial institutions, not just in Singapore, everywhere actually.
Okay, thank you.
Yeah, thank you.
So, so we have our last speaker, William Temple, CEO and co-founder of Empotech. Unfortunately, he's unable to join us real time because of
rightly or wrongly, that's a different matter. But this is nothing to do with crypto. This is entirely enterprise grade use case, and that's been widely accepted in various financial institutions, not just in Singapore, everywhere actually.
Okay, thank you.
Yeah, thank you.
So, so we have our last speaker, William Temple, CEO and co-founder of Empotech. Unfortunately, he's unable to join us real time because of
rightly or wrongly, that's a different matter. But this is nothing to do with crypto. This is entirely enterprise grade use case, and that's been widely accepted in various financial institutions, not just in Singapore, everywhere actually.
Okay, thank you.
Yeah, thank you.
So, so we have our last speaker, William Temple, CEO and co-founder of Empotech. Unfortunately, he's unable to join us real time because of
rightly or wrongly, that's a different matter. But this is nothing to do with crypto.
Okay,
this is
hello everyone. Thank you
enterprise
for being
grade
here
use
today.
case,
My name is William Temple, and I'm the CEO and co-founder of Empotech.
not just in Singapore,
Today I'm going to be sharing.
Everywhere actually.
Okay, thank you.
Yeah, thank you.
Okay, sorry, there were some technical difficulties we face just now. As I was saying, William is unable to join us real time, but he has recorded his presentations on the building an intelligent and secure grid edge. So just a quick introduction of William. So he is the CEO and co-founder of Empotech, Singapore-based company applying Internet of Things and edge computing technology for building energy efficiency and facility management. He has 10 years of international experience in energy, smart buildings, and operational technology ranging from R&D to operations and business development. So we will play William's pre-recorded presentations. Applying Internet of Things and edge computing technology for building.
Okay, hello everyone. Thank you for being here today. My name is William Temple, and I'm the CEO and co-founder of Empotech. Today I'm going to be sharing about
and operational technology ranging from R&D to operations and business development. So we will play
building an intelligent and secure grid edge. The overview of what I'm going to be covering is introducing what is the grid edge. I'm going to be talking about how smart buildings and the smart grid are both becoming more and more interconnected thanks to digital technology and the decentralization that's happening in energy systems today. I'm going to talk about data and its role being shared between different organizations and different aspects of the energy system. And that leads to cyber threats. So I'm going to touch on some of the cyber threats that are out there today and how both vendors and end users in this industry can take steps to protect themselves and ensure that they're delivering a secure system. First, to make sure everyone's on the same page, I want to talk about the grid edge. This is a sort of an industry buzzword. Some of you may have heard it, some of you may not have. But essentially what it is energy-related systems, software, hardware that are being deployed sort of at the home and business level of the system, not so much at the transmission and distribution layer or power generation. So we're talking about low voltage systems, a high number of systems, as opposed to the more centralized technology that you see at substations or sort of in the more traditional power grid domain. So examples of what you would consider a grid edge technology would be advanced metering infrastructure, automated demand response, where you have energy assets like energy storage or flexible loads that are within many different customer premises. You've got rooftop PV systems, and then things like smart home devices or smart building systems, which can lead to more responsive demand side assets, which can then interact with the power grid and with energy markets. So what we see in the industry is that traditionally there's been a lot of separation between the power grid and then sort of the customer aspect of that in buildings, businesses, and residential households. So you have historically separate vendors, separate systems, not a lot of interaction between those two worlds, except for, of course, the physical electricity supply and sort of the revenue grade metering system that would allow the utility company to bill those customers. But what we see today is that the lines are becoming a lot more blurred as integrated intelligent systems that involve both the generation and the consumption of energy are being deployed. So there's actually a lot of interesting examples of this happening in Singapore today. One example would be the Solar Nova program, where rooftop solar panels are being deployed on a large number of HDB housing blocks. So this means that you have massive distributed generation, and all of those distributed generation assets need to be monitored and tracked in a central manner. But there's also a local aspect of that within that particular housing block where you need to understand the net load with your local generation, your local demand, and you need to be able to monitor what's happening within that facility. Similarly, we see, especially now, a lot more interest in electric vehicles and a much wider deployment of EV charging. And this is typically, of course, deployed in public and private property. So car parks, condos, shopping malls. And so that again leads to an aspect of the solution that is within sort of the grid edge under the domain of a property owner, and then also a grid connected aspect where the charging needs to be managed and scheduled. The load on the electrical system needs to be catered for. So there is sort of a macro and a micro element to that. And then finally, one of the interesting technologies that's gaining more and more traction in Singapore is district cooling. So you may have heard of some of the district cooling plants that have been deployed both at Marina Bay, Changi Business Park, Biopolis. So what this is doing is taking the air conditioning system that you see usually within one particular building and then scaling it up to a district level where multiple buildings are sharing the same cooling system. And there's a common plant room. So this is again kind of transforming what you would typically see at the edge within a particular building and making it much more of a utility scale thing that still has touch points within the customer premises and the building, as well as at the central grid operator level. So what we see from our perspective in the market is that data is really the critical layer that connects all of these different assets and all of these different systems. And there are a number of issues that come up when you're talking about the type of data that you need to manage a large-scale intelligent energy system. So we're talking here about things like sensor readings, event notifications, control commands. So the common data issues that you see would be data quality. If you don't have a sufficient volume of data, if you don't have a sufficient granularity of data to be able to make decisions and monitor and optimize assets. Data reliability is a key issue. If your data is intermittent, or if the timescales are not appropriate for what you're trying to do, or they drop out. And then you have interoperability, where sometimes data can't be exchanged with the systems that need it, or the different parties that need to access that data. And then finally, security, which is a major issue that we'll touch on in the following slides. But what I wanted to illustrate here on the right side is how this data is actually being used in sort of emerging energy systems. So you have on the building scale, sort of at the grid edge, you have digital twins that are being developed and deployed for different types of businesses, different industries. You have greater sustainability reporting, which we're seeing with more and more businesses adopting greater monitoring of their energy consumption, reporting for corporate governance and ESG targets. And then, of course, you have things like facility management and maintenance, where you have a large volume of data being collected to help optimize that building locally. But you have innovative business models such as energy as a service, where that process can actually be centralized and managed at a much larger scale by vendors who take ownership over all aspects of the solution. So data is really a critical thing. It needs to be high quality data. It needs to be also secured, because obviously there's a lot of operationally and potentially personally sensitive data that can be collected as part of a system like this. And so that leads us to the security theme. I think it's not a secret that the energy sector has been a target in the past for both state and private actors that are looking to cause harm to companies or certain countries. I think one of the early efforts to look into critical infrastructure security was in the US through ICS CERT. They released a number of threat reports around 5-10 years ago. And consistently, the energy sector was among the most highly targeted sectors. So I've included here a excerpt from a 2016 report where you can see that energy had 46 documented cyber incidents. Other areas like manufacturing and water were also highly targeted. And this has stayed true even now, 5-6 years later, where according to an IBM report, the energy sector was the third most targeted sector in 2020 for different types of cyber threats. So given that we know energy is a sector that is a target for cyber actors, how do businesses need to approach that? So even if you're not operating a SCADA system, if you're talking about more grid edge or smart building type of systems, you need to be aware of the types of threats that are relevant. So that might include things like ransomware, which I think we've heard a lot about in the past year with the issue in the US with oil and gas. Things like data theft and botnets are also issues. So let's talk a little more about how, both from a vendor standpoint and also from an end user standpoint in this sector, you can take steps to protect yourself. So AmpoTech is coming actually from a vendor perspective. So I'll share a little bit about how we think about this problem and how we recommend that other vendors should think about it as well. So I think the most important thing to mention when you're talking about cybersecurity, especially for operational systems, is understanding the context and understanding risk. So the starting point is that no system is going to be 100% secure, and you can't really think in absolutes when you're thinking about cybersecurity, because you're dealing with dynamics both in terms of how the system is operating and how the threat landscape is evolving. So as a key starting point, I think you need to understand what your system is doing and how it's being used by a customer. So if you're talking about, let's say, an IoT business or a metering business, you need to understand, is your product being used in households? Is it being used in enterprises? Is it being used in critical manufacturing or critical infrastructure like, the MRT or the power grid for, a Genco, for example? So understanding the customer and the level of criticality and the types of uses for those products is extremely important. So once you understand sort of the impact on the context, you also need to assess the likelihood. So this is something that can be done using tabletop exercises. There are certain threat modeling software tools or risk assessment software tools that can help with this process. It's also something that can be done through consultants to help you kind of bring in that expertise to think about different threats and different potential likelihoods. So the other thing that vendors need to be able to do is to think about security and think about some of these issues early in the design stage, as opposed to sort of retroactively trying to go back and correct issues that may exist. So it's very important when you're first conceiving of your product or your service, you need to be aware of typical cybersecurity issues and vulnerabilities that are typical for those types of systems. So what I have here on the right side is the OWASP top 10 for IoT. So this is essentially a list of the top 10 most common vulnerabilities that you find in Internet of Things devices. So, all vendors should be aware of these types of issues, and these things should be thought through and as much as possible avoided when you're first sort of developing your system. Now, if we look at it from the other side, if you're a buyer, if you're an end user of intelligent energy systems, what should you do to think about cybersecurity? So I think the first step is, again, to kind of understand the threats and best practices. So sort of a basic level of education and understanding. I think CSA in Singapore has done a great job of raising awareness. They have some excellent resources and reference material that can help with this. There are international standards like IEC 62443, which can serve as a good starting point to understand the way to think through risk-based cyber assessment. The second step, I think, is to understand what we call your attack surface. So this means essentially all the different entry points or areas where a malicious actor could gain access to your system or cause harm to your system. So these can be things like, web servers, field devices, anything that is a potential way for an attacker to get into your system or your network and potentially move from there. So some of the key principles to think about are understanding the interfaces in your system. So if you have many different vendors, many different systems that are owned by different parties that need to work together, this can lead to more risk if those interfaces are not properly secured and managed. That leads to the third step, which is defining your requirements. So if you're approaching a project early on in sort of the scoping phase, you need to really think through what the appropriate security measures and standards and practices are based on your risk and your use case. Which is similar to what we talked about from the vendor side. So, if you underspecify, then you're going to be relying on vendors to provide what they feel is best, which may or may not be appropriate depending on the vendor and the context. On the other hand, if you put in very heavy cybersecurity requirements, that's going to lead to more cost for the project. So something like, OT requirements from highly secure facilities is not going to be appropriate for your average, commercial building or business if they don't have a lot of mission critical stuff. And then finally, don't neglect sort of the life cycle and the ongoing support aspect of security and of managing your system. So sometimes we see customers that think that a system is a one-time thing. You deploy it, you configure it, and then the story stops there. So unfortunately, the threat landscape is constantly evolving. Software and devices need to be updated, they need to be managed, they need to be monitored. And so it's very important to think about that when you're scoping a project, to make sure that you've budgeted for ongoing support and maintenance, and making sure that your system is going to stay secure and stay high performing over a long period of time. So finally, I'm just going to leave you with a few points about our company. If you're interested in getting in touch, I'm happy to speak and answer any questions. Ampotech is an AIoT company focused on the building sector. We help businesses collect, analyze, and integrate power consumption data from equipment and from buildings and sites. We process data from customers in 8 countries, over 6 million data points a day. We're a venture-backed startup company that came out of a local A*STAR affiliated research institute. And we've been fortunate to be recognized recently with a number of awards, and we're continuing to grow the business now outside of Singapore. So I thank you very much for your attention, and I'm happy to take any questions. Thank you.
Okay, so William is unable to answer your question live. So if you have any question, please put it in the chat box, and we'll get him to reply to you offline. So with that, we have come to the end of this afternoon's workshop. And for those who like to look back on some of the presentations, we will be sharing a private link for you to access the recording of this afternoon's seminar. Are you able to see? So yeah, so what I'm showing here is actually the QR code to our survey feedback form. So please fill in the feedback form, and then then I think within 3 days or so, we'll give a link for you to download at least the PDF file of the workshops. Yeah. So right, I thank you for everyone who's managed to stay until this time, and I hope that in the coming edition, 2022 edition, we will be able to have this workshop physically, and then we'll be able to interact and mingle. So thank you for your time. Thank you.
Thank you.